right, folks, this is going to be our explanation solution video. And hopefully what you are doing while you watch this is looking at your own work, editing, making any corrections, writing down any notes, trying to find patterns of where you make mistakes, that sorts of thing. Now, if you need to pause this, of course, you can always do that. You can always rewind until you get through what you need to get through for the assignment. So let's start out with ABC. The original document had a D, and I did take D off because it could be a replication, depending on how you saw one of the other patterns. So if you did D, don't worry about it. Just kind of focus on ABC. Excuse me. So what are we doing here? First of all, we're trying to identify a pattern, and we're trying to write the next three terms using your pattern. Okay, and then we're going to write a sentence kind of telling us what the pattern is, and then talk about what the 10th number might be. Now, what's really important to remember, especially in terms of patterns, is that it is possible that some of us don't necessarily see the same pattern, or that we see a different pattern. As long as the pattern holds out, then that would be okay. Okay, so I'm just going to kind of point out some of the ones that might be in common here. So in 1, 2, and 4 for the pattern A, I've had several people point out that this could be doubling the previous number. Okay, so if we were thinking about it in terms of doubling the previous number, okay, then our next three values would be 8, 16, and 32. Okay, if we doubled 4, we got 8, doubled 8 to get 16, and so forth. That is one way you could see this pattern. If you did that, okay, your 10th value would be 1024. Now, that might not be the pattern that you saw, okay? I also have seen people say that this could be more of a geometric sequence where there's not a consistent change every time. For example, adding 1, adding 2, adding 3, adding 4. Okay, because there's a difference of 1 between 1 and 2, a difference of 2 between 2 and 4. If that was the case, if you saw the pattern that way, then your next sequence, okay, or the next three terms in the sequence would be +3, which would be 7, and then +4, okay, which would be 11, and then +5, which would be 16. I think if you continued that on, I've deleted what mine would be. If that was the approach you took, I think you're somewhere in the 40s. I think it's like 46 if you went through it that way. Okay. Of course, are there other approaches to the pattern? As long as it stays consistent from 1 all the way through, that definitely would work. Okay. Now, pattern B, of course, is the easiest one that we have here. We have a repeating pattern, an ABC pattern. 1, 2, 4, 1, 2, 4, 1, 2, 4, of course, is our next three. Okay. Now, in terms of the 10th term, okay, we have 9. If we list the next three terms, we have 9. So, of course, the 10th term would be a 1. We would start that pattern over again. Okay. Now, looking at the final pattern here, this one is a little more clear that we are doubling, okay, that previous number. And that is definite here. So you might have had that same answer for number 1. You might have thought, that you definitely had to have this pattern every single time. So you might have thought that you ended up with 2 of the same. That would have only happened depending on the way you viewed pattern A. Okay, if you did view them as the same, that's no big deal. There's nothing wrong with having the same pattern. You would have just kept on with those sequences. Of course, if you doubled that, you're going to have 32, 64, and 128 as we move forward here with that pattern. Of course, the 10th term in that sequence would have been 1024, okay, which is, if you viewed it that way in pattern A, you may end up with the same answer for that. Okay. Now, the only thing I want to point out here is in the past, I've had a lot of students ask why in pattern A they can't say adding 2 would be a pattern because it doesn't hold up for the first number in there. Okay, we don't add 2 to number 1. Remember that when we're saying we find a pattern, it has to stay significant throughout the entire range of the pattern. Okay, so if you have other options that you want to run by me, feel free to do so. We can talk about that in class if you like when we come in on Thursday. All right, so number two is a lot going on here. We've got a shape-like pattern. Okay, we might want to be seeing this in some of our younger grades, but nonetheless, it does sometimes throw some of my older students because they want to focus on this as an entire object. In reality, this one is a lot easier if you focus on the individual characteristics here. Pretty much what do we notice? We notice all of these shapes or all these figures have circles in them. So that's where I would have started. If I were drawing out the next 3, okay, I'm going to see if I can enlarge my screen here and kind of draw this along with you. But if it were me and I were doing this, I would start out by putting those circles in because we know that we see that in all of them. So I'm going to switch to the draw menu. And I'm going to use my active pen here to kind of draw in these circles. All right, everybody has that. So thinking about the individual traits, I know I've got eyes. I don't think that's intended to be a nose there, okay? So I think we've got eyes to deal with, we have a smile to deal with, and we have the rays on the outside of the sun, okay? So let's start with the smile face or the frowning face. That's probably the easiest pattern. If you look across all the suns, we see happy, sad, happy, sad, happy, sad, happy, sad. So it should make sense then that this is happy, sad, happy. Okay. If we count our shapes, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay, so what we should notice so far is that all of our odd numbers are happy and our even numbers are sad. Okay, hold on a minute. I think that's right. Let me make sure I've done this correctly. So happy, sad, happy, sad, happy, sad, happy, sad, happy, sad, happy. So it should be our odd numbers that are happy and our even numbers that are sad. Okay. So far I've got circles, I've got the smiley face. Let's look at the eyes, okay? I only see eyes on 2 specific shapes, and that's here and here, okay? So that's the 3rd and the 6th. So what does that tell us? Every 3rd figure is going to have those little triangle eyes. You might have said that was multiples of 3. Okay, so the only multiple of 3 we have here is, of course, that 9th shape. Okay, so we've taken care of circle, eyes, and smile. So now let's look at the rays. Okay, we have this sun and this sun, and this one and this one that have rays. So that's the 3rd and the 4th, and the 7th and the 8th. Okay. Now, students sometimes struggle with how to say this, okay, because it's hard to find a pattern between 3, 4, 7, and 8. One of the easiest patterns I have found is to do every 4 suns and then the one before it, okay? I have a lot of people who ask, why can't I do every 3 suns? Because it's not necessarily every 3rd one. If you look at this, every 3rd one would be multiples of 3, and we don't see that. It's actually kind of driven by the idea that this 4th sun is here, and then we're going to give rays to the one before it, okay? So I know that the next multiple of 4, or the next 4, would be the 12th figure, and we don't have to show that here. But we would have to put rays on the 12th one and the one before it, which is, of course, the 11th. So we would have rays on this sun, right? So it asks us, can we draw the 63rd sun without drawing 63 figures? Okay, so let's go back and look at the traits we've seen. Now we know no matter what, 63rd son is going to have a circle. Okay, so let's try to put his smile or his happy or sad face. 63, of course, is an odd number. Okay, so what pattern did we see here? Odd numbers had smiley faces. Okay, so we took care of that. Now let's think about the eyes. The eyes, we said, were multiples of 3. Okay, we had the 3rd son, the 6th one, and the 9th one. So we look at 63, and it is a multiple of 3. Okay, we could divide it, it's 21. So that means it's going to have some eyes. Okay, now our last trait we're going to look at is the ray. Okay, and how do we say we figured that out? All multiples of 4 and the one before it. Okay, so if I took 63, I should kind of recognize immediately that it's not divisible by 3 or by 4. I'm sorry, it's not a multiple of 4. So what we want to ask ourselves after that, is it the one before a multiple of 4? Okay, so if we were going along this process, okay, let's think, what is 64 divisible by 4? Because that is the only way that we would need rays on this as well. It's not a multiple of 4. 63 isn't. So what about 64? Okay, if we do that, we see that it is very much a multiple of 4. 16 times 4 is 64. So in that case, it is the one before multiple of 4. So it's got to have those little rays on it as well. Okay, so there's my 63rd son without drawing all 63 figures. So we looked at the pattern. Okay, that's what our evidence was, and then we extrapolated it. We kind of looked into the future without having to draw all those. Right, so let's look at a new pattern here. Now, for question number 3, trying to do this question, maybe necessarily in the order it's here, might have been a little bit harder. So if you struggled with 3 and you couldn't really come up with what you felt was a good idea, maybe if you want to stop and pause this and try to do it starting with B, C, D, and then come back to A, that might help a little bit. Okay, so if you want to do that, you can give you a chance to pause. And if not, then I'm going to kind of take off with this. Okay, so with me, when I started approaching this, it wants us to know in words how we're going to create this picture. So we want you to draw 25 pictures. We want to know how many toothpicks are we going to need to construct this and what's it going to look like. Okay, so if all you wrote was 25 individual squares together, well, I mean, that's true, but we need a little bit more detail than that. So let's start with part B, okay, and then let's see if that can help us get a little more detail in part A. So the first thing I want to do with these is I want to kind of make myself a little bit of a table here, okay? And I'm going to just stick it right here. And I'm going to put in here V for vertical toothpicks, H for horizontal, and T for total, okay? So we've got figure number 1, and remember we said we were always going to let our N or our F or whatever we're using represent the number of the order of this. So figure 1, I've got figure 2, and I've got figure 3 that I can gather evidence from. So we're going to look at vertical toothpicks first. So here in figure 1, I can see 1 here and 1 here. So we have 2 vertical toothpicks. For horizontal, 1 here and 1 here, okay? So 2 horizontal for a total of 4 toothpicks in figure 1. It's very small. So let's go on to figure 2. Vertical, I have 1, 2, 3 vertical, and I have 1, 2, 3, 4 horizontal, okay, for a total of 7 toothpicks. With picture 3, okay, 1, 2, 3, 4 vertical, 1, 2, 3, 4, 5, 6 horizontal for a total of 10 toothpicks. Okay, so I'm kind of gathering some evidence here. I'm just getting some information for myself. So looking for B, it wants me to give some sort of a model, okay, or an expression. That's what a model is, for how many vertical toothpicks are going to be in any picture. Okay, so if I'm not talking about the first or the second or the third or the 50th, just any picture in, how many vertical toothpicks are going to be there. So let's look. The first thing we want to do is we want to kind of think about how does this number of vertical toothpicks relate to the number of the figure. Okay, so here in the first figure, I had 2. In the second, I had 3. And in the third, I had 4. What obvious pattern are we seeing between these two values? Whatever the number of the figure is, there's one more vertical toothpick involved in that. Okay, now that makes sense here because basically what we're making is squares. Okay, and each n represents how many squares is in here. So we got to have one more. We got to have the n piece always. That's the difference in terms of what we're doing here. Okay, so if I'm looking at vertical toothpicks, that's always going to be n plus 1, okay, or f plus 1, or picture plus 1, however you wanted to say it, however it made sense to you. Okay, so let's move on to C. Model the pattern for the number of horizontal toothpicks used to create any picture in. Okay. All right, so let's look at horizontal. So when we're trying to write this pattern, now we want to just think about how the horizontal relates to the number. So in figure 1, I had 2. In figure 2, I had 4. And in figure 3, I had 6. So what is the relationship we see there? If we double the number of figures, that tells us our horizontal toothpicks. That should make sense because we have a top and a bottom for each one of the squares. Okay, so how would I show that? 2 times n or 2n. You might have also said n plus n. That would make sense as well. Okay, now part D asks us to say model the pattern for the number of total toothpicks. Okay, now what we hope we see here is that the total, of course, is just the vertical plus the horizontal. Okay, if what we want is vertical plus horizontal, then all we have to do is take those expressions that we have up here, n plus 1, that's vertical, plus 2n, that's horizontal, and that's going to equal the total. Now, some of you might have be comfortable in your algebra. You might have combined like terms. 3n plus 1 is the total. If you didn't, it's not a big deal. Okay. Now let's go back and let's look at A. It wants us to describe in words how to create picture 25. So what do we know? We know we're dealing with the 25th picture, n is 25. So in terms of vertical, it's going to have 26 vertical toothpicks. We know that it's going to have 50 horizontal toothpicks, 25 plus 1 and 2 times 25. Okay, and we know it's going to have a total then of 76 toothpicks. Okay, if we write this out in a sentence, and hopefully you will, it's kind of hard for me to write on here with an active pen a whole sentence, but if you write this out of the sentence, picture 25 would contain 26 vertical toothpicks along with 50 horizontal toothpicks for a total of 76 toothpicks to create 25 squares. Okay. So now question number 4 is kind of an opinion-based question. There's no really right answer here. That's totally up to you. So you may have a different response. I'll be looking at these as you guys turn them in. This is elementary students often get hundreds charts. 2 patterns you might expect third graders to find, and 2 patterns that they might not be obvious. Okay, most of our third graders will pick out the tens along the left side. Most of them will pick out, the, of course, that everything ends in 7, everything ends in 8, everything ends in 9, kind of as we go along these columns here. I'm sorry, lost that for a second. So let's keep looking for other patterns they might not recognize as often. Okay, so what about this diagonal? Sometimes that pops out. That's your 11s, right? Okay. What about if we go to and we start looking here among the others? There are many patterns here. If we talk about even numbers, if we were to start having the students color in even numbers, you would see we had every other one. That's a pattern that third graders might pick out. In terms of our multiplication facts, okay, this can be useful. Honestly, it's more common that we might see this hundreds chart written from 1 to 10. Okay, so this example is one example of a hundreds chart. It's not the only kind of hundreds chart. If we had a 0 through 10 across from time to time, we can see actual multiplication facts almost always just in rows, okay, depending on the one, of course, that they would use. So again, individual question. Everybody might possibly find something different there. All right, so I did put these pieces of information up here. I'm talking about how to convert fractions for decimals. I think most of us honestly could do A, B, and C from the conversation we had today. Part D is one we're going to pick up and talk about a little bit later. So I'm going to kind of see how you handle it, but not really go into the answer for that one right now. Right now, what I want to see is we know that this is 3 ones. And hopefully from our conversation today, we should be able to read this as 142 thousandths. Okay, so we can show that part as a fraction. If you wanted to make the whole thing, this could be your mixed number if you wrote it like this. If you wanted to make it an improper fraction, then of course this would be 3,142 over 1,000. Okay, 0.9, of course, would be 9/10. 0.03 would be 3/100. Okay, so again, like I said, this is going to be what I'm going to come back to in our next session. Getting back into that place value pattern, here we go with a very similar exercise to what we did earlier today. Okay, what I've noticed that some students do is they find a way of writing out that place value chart just to have a visual to look at. Everybody's kind of a little bit different, but they might use ones, tens, hundreds, okay, and then I'll see them use TH for thousands, and then TTH for 10,000s, and HTH for 100,000s, just to have a visual to look at. It's absolutely not necessary to do that. However, it just helps others track like how many spaces they move forth. Okay, so we are starting out with 3.54 hundredths. Okay, 3.54 hundredths. And we want to move that to 35.4 and then see which unit that is. Okay, so let's first of all, let's show, okay, where our 300ths would be. All right, let's kind of visualize where that would be at. Okay. So I'm going to draw some blank spaces here. Okay, so if I have 3.54 hundredths, that means our 3 has to be sitting in the hundredths place. Okay, if I put the 3 here, that would give me 354 thousandths. That wouldn't be right. Okay, so I want that 3, I want it in the hundredths place. Tenths, hundredths. So there's my 3. That means that 5, 4 has to be over on the other side. Okay. Now, even if this is hard for you to kind of visualize where that's at, if you think about it as just a number, and you know you're counting hundredths, if it changed to 35.4, which clearly it did here, obviously we moved down 1 space in place value. How do I know that? First of all, I know we went down 1 space. I know it's 1 space because the decimal moved 1 number. Okay, it went over by 1 number. I know it's down because I got more. It went from being 3.54 to 35. So whatever I had to have traded down in order for me to get more. Okay, now I want you to stop and think about that if that doesn't make sense. It would be like trading dollars to dimes. Obviously, you would get more dimes than you had dollars, so you have to be going down to a smaller amount. Okay, so I went down 1 place. If I'm reading hundredths, okay, trading down 1 space, okay, would have to be thousands. Okay. I have 3.5 approximately hundredths. When I traded down, I get more thousandths. Now remember, these are fractional pieces. So even though it sounds bigger, okay, that means it's a smaller fraction. Okay. So let's see what we look at when we go to B. Okay, so we started with 3.54, and that's hundredths. And that value changed to be 0.354, and we don't know what the unit is. So let's look at what actually happened to the value here. We had the decimal that has moved. It's no longer behind the 3. Now it's in front of the 3. So we had 1 movement or 1 position or 1 place. Okay. And it went from being 3.5 to being 0.35. So it got smaller. So since it got smaller, that tells me I had to be trading up. Okay. So hundredths, this new unit has to be bigger than that. Okay. Because it took a whole bunch of these hundredths to make, we don't even have 1 of these. Okay. So let's look at our place value. If we're at hundredths, okay, which is right here, and I'm trading up to bigger, then this is going to be tenths. Okay. So let's go back now. Look at part C. Okay. Part C and D kind of do the opposite of A and B. Instead of giving you a number, they give you a unit. They want you to change it. Okay. So I'm at 3.54 hundredths, and I want to go to ones. Okay. So here's ones, and over here's where I am. So trading up once would get me to tenths. Trading up again would get me to ones. Okay. So I've traded up twice. That should mean 2 decimal places to the left. Okay. So if I move it once, I'm in front of the 3. And I know I've got to move it again. We can't just leave it like that. We have to use 0 as a placeholder. If we ever run out of places to move, got to use 0. So we are looking at 0.0354 for ones. Okay. Now look at the last one, 3.54 hundredths. And we want to move it to 10 thousandths. Okay. So 3.54, where we start, and that's hundredths, and we want to go to 10 thousandths. So here is 10 hundredths. There's thousands and 10 thousandths. So this time I'm trading down twice. So I'm trading for smaller things. So that should mean this number is going to get bigger. Okay. One movement, that would be going to thousandths, like we showed above. Two movements, that's going to 10 thousandths. So I have 354 10 thousandths. Okay. Question number 7 is very much like 4. It's going to be an individual thing. Okay. And I'm very interested to read what you guys think about this. We're kind of at the stage where I get a lot of students who have had some really good conceptual teaching, others who have not. So it'll be really interesting to see what you guys think. And this is an idea that we will be talking about pretty much for the eternity of this class. Okay. So again, once you've watched this and you've made your edits, there are reflection questions to answer. Okay. And that will be once I view your homework submission, which you should have submitted that before you're watching this video. I'll know that you've seen the video, and then you'll have your reflection questions submitted and answered. All right. See you on Thursday.